That's
You really truly will see. Hey guys, I'm teaching now. This isn't hangout class, it's math. Okay. So with this, it's really awesome because you guys have come so far. Most of you were able to see, I mean, almost every single one of you, I think every single one of you did not break the forbidden rule. Because of that subtraction sign, we have to rewrite this. We have to rewrite this as 2x minus 3 times 2x minus 3. And then we will do what? You tell me.
5 times 2x.
Double distribute. Very good. So we'll take 2x times 2x, which is
4x squared.
Now guess what? You guys are doing so much better at not forgetting your x squared. So that's awesome. Good for you. And then 2x times negative 3 minus 6x. And then we have negative 3 times 2x. Good. Minus 6x. That's usually where I see people forget an x. And then negative 3 times negative 3. Then we combine like terms. 4x squared, no other x squared, minus 12x plus 9. Very good. How many of you got it 100% correct? Hey, that is so awesome. Good job. All right.
I got you, Dad.
What's going on out there?
I give me no paper. You know.
Okay, yesterday we started our probability unit. Now I told you, and I wasn't lying when I said our probability unit is going to get harder and harder each day, and it's going to build every single day. We're building on what we learned yesterday. So in probability, this is 3-2, second lesson. So yesterday we learned that probability is the likelihood that an event is to occur. Probability is the likelihood an event is to occur. And we see probability written a few different ways. We see it written as a decimal, and then we can convert that decimal into a percent. We take our decimal and move it 2 places, and that would be right there. So that would be 3.5%. Now today and yesterday we did see these probabilities written in 3 different ways. We saw it written like this, so 1/6. Now you can find the actual percentage by doing in your calculator 1 divided by 6. And if you do that, you'll get 0.166 continuing. So if we wanted to know the percent, we'd move our decimal 2 places. That'd be 16.7%. Is everybody comfortable with that? We saw all 3 things yesterday. Okay, awesome. Now, yesterday we learned that if you're dealing with 2 independent events, and we know independent means the first event doesn't affect the second event. The likelihood of the first event doesn't affect the likelihood of the second event. So recall that if you have 2 independent events, then you can find the probability of both events happening by multiplying, I'm going to underline that, by multiplying individual probabilities. So if they are independent, we can take the probability of event 1 times by the probability of event 2. Did I say plus?
No.
So we don't add the probabilities. We multiply the individual probabilities. Very good. So for example, if we had 7/36 was the probability of the first event happening, 8/12 is the probability of the second event happening, we can find the probability that both events happen by multiplying the individual probabilities. So I multiplied straight across. 56 over 432. Then I took my calculator, did 56 divided by 432. I got 0.129, and that is 12%. So there's a 12.9% chance that both events will happen. Does that make sense? We learned that yesterday, though, right? So I'm just recalling. So we'll use that again today. So this isn't new, so I'm going to go on, because you should have notes on this. All right, so let's just get to it. Let's draw an area square. We're going to practice with area squares, and then we'll move on late in just a couple of minutes. So now it's going to be more complicated today, because you're not going to be given the probabilities. Every problem we did yesterday, they straight up said to you, hey, this is the probability of this. This is the probability of this. Today you're going to have to use your knowledge to determine the probabilities. So let's look at this one. We have this event 1, spinner 1, and event 2, spinner 2. Does everybody see the 2 spinners here? Now, notice if you look at this, does it say anything about the probabilities? No, right? But yesterday we were given all the probabilities. So in this one, we've got to determine the probabilities. Well, look at spinner 1. Look at spinner 1. We have 1, 2, 3, and 4. And they're cut equally, right? So there's how many pieces? 1, 2, 3, 4. So there's a, right here, to land on piece 1, there's a 1 out of 4 chance of landing on piece 1. Does that make sense? Now there's a 1 out of 4 of landing on piece 2, right? There's a 1 out of 4 of landing on 3, and a 1 in 4 chance of landing on 4. Now, if you want to know the percentages, you can do that. 1 divided by 4 is 25%, but I'm just going to leave it like that. Does everybody understand how I did that? Because for some reason, first hour, when I set them free, they're like, I don't know how to do that. Do you know how to do that now? Do you? Okay. Moving on to this next spinner. All right, so here's my next spinner. Now this one's different. Is it cut equally? No. So we can't say 1 out of 3, 1 out of 3, 1 out of 3. We've got to think about this one significantly more. All right, so what I want you to look at is we were given that this is 90 degrees. So right here is 90 degrees. That's not the probability. That just means that this green piece takes up 90 degrees. Well, how many degrees total? 360 degrees in a total circle. Very good. So, to find probability, you take the favorable outcomes, which is 90 degrees, divided by the total number. So we're going to find the probability by taking 90 degrees divided by 360 degrees. A full circle is 360. If you do that, you're going to get what? 0.25, awesome, which is 25%, right? Okay, awesome. So the probability of landing on green is 25%. Questions? Okay, now let's think about it. If this is 90 degrees, won't this be 90 degrees?
Yeah.
Yes. Now, also we could say we know that a half a circle, the two angles will add to be 180. So we can take 180, subtract 90, and we get 90 degrees, right? What's the probability of landing in a 90 degree piece? You just did it. 25%. Very good. So there's a 25% chance of landing on blue. And then what about red? Good, 50% chance. You could do this a couple ways. You can either just say, well, I have 25 and 25 already, so that's 50. That leaves me with 50% chance. Or you could say, I know that this is 180 degrees. So you could have done 180 degrees divided by 360 degrees to find the probability, and you get 50%. Does that make sense on how I did that? Like I said, guys, I set first hour free, and then they're like, I don't know how to do that. Yeah, we're all good. Okay, awesome. So now to list your area squares. The reason we list area squares is so that we can calculate probabilities quickly. So on event one, we had a 1, a 2, a 3, or a 4, right? We could spin 1, 2, 3, or 4. And there's a 1 in 4 chance of landing on 1, 1 in 4 chance of landing on 2, 1 in 4 chance of landing on 3, and 1 in 4 chance of landing on 4. I draw this, draw my lines. I'm going to set up my area square. Questions on that? Now on event two, there was a blue and a green and a red. So then I'm going to list the probabilities. There's on blue, there's a 25, so 0.25. I'm going to write it as a decimal so that when I calculate it, it's just correct. So there's a 25% chance of landing on blue. On green, there's a 0.25% chance, and on red, there's a 0.50, 50% chance. Then I draw in my little lines. Are we all okay? So now to find the probability of both things happening. So to land on IB, and I'm not going to write them all out, but to land on a 1, not an I, sorry. To land on 1 and B, to find the probability of both of those events happening, we multiply the individual probabilities. So take your calculator. You'll do 0.25 times by 1 divided by 4. What do you get? You should all practice so that if you get something different, you can know if you typed it in right. 0.625? So you got? Good. So that's 6.25%, right? So 6.25% chance. Is everybody okay with that? So then we're going to do 0.25 times 1/4 again, right? Well, did we already do that once? It's going to be the same. So I'm going to say 6.25%. Once again, 1/4 times 0.25, same thing. So 6.25, 1/4 times that, 6.25% chance. Let's see if this is different. 0.25 times 1/4. It's the same, right? So I'm just going to quickly, 6.25 is the same here. 6.25, 6.25. All right, now this one is going to be different. 0.50 times 1/4. Good, 12.5% chance. 12.5% chance. 12.5. Now, once again, I'm checking 1/4 times 0.50 is 12.5. Do you see how I filled in my area square? Okay, so now we can use that to answer the question. What's the probability of landing on a 1 and red? 1, red. 12.5% chance. Now, I'm not even going to use my area square on this next one to show you how it's almost easier. If a problem doesn't ask you to make an area square, you don't have to, and it's easy just to look and multiply the individual probabilities. What's the probability of landing on an even? How many times does that happen? 2 out of 4, right? 2 and 4 are both even, so it happens 2 times out of 4. So that's the probability of landing on an even. What's the probability of landing on blue? 25%, so 0.25. So I'm going to multiply the individual probabilities, and that will be the probability. You should get 12.5%. All right, probability. Did you like the area square better or that way? Just curious. Area square better or just listing out the probabilities? Me too. I like to just list the probabilities. So what's the probability of landing on an odd? How many times? 2 out of? Yep, odd is 3 and 1. Those are odd numbers, so that happens twice out of 4. So 2 out of 4, and then landing on green. What's the probability of landing on green? 0.25, and so we'll get 12.5% chance. Do you have any questions? Are you sure? Okay, are you ready to do it on your own? Okay, so do problems 1 through 3. Now I messed up on number 3. It's you should have these spinners on your worksheet and you don't. So on number 3, everybody go to it right now. Draw these spinners the exact same way, and then you'll have them. Because I forgot to draw them real quick. And to the close little details, you're gonna not understand it. Okay, so now we've been modeling, finding probabilities using area squares. Now I'm going to teach you how to do it using a tree diagram. Now the reason we're learning another way is because you might like this way better. Not only that, but you will not be able to use an area square if you're dealing with 3 events. So far, we've only done 2 events, right? Right. So once you deal with 3 or more events, you'll want to use a tree diagram, which I like tree diagrams way better than I like area squares. So this is how we're going to do this. So once again, just a tree diagram is a different way to model the sample space and their individual probabilities. So let's go ahead, and I'm going to draw a tree diagram for these 2 points. So in this one, I only have 2 events again. Here's my first event, my second event. Does everybody understand? Are you paying attention? Okay. So everybody listen carefully. I promise you're going to be lost. First hour was so lost. I really just think, though, that they were just not quite with me. So on my first event, I'm going to flip a coin, and I'm going to list the possible outcomes now. On my first event, I'm either going to get a heads or a tails. Does everybody understand that? Are you sure? My first coin I toss is either a heads or tails. I'm going to cross it out. We've had event 1 happen. Now a tree diagram is just a way to show all the possible outcomes, including their order. So let's say I flipped the first coin and I got a heads. Well, I'm going to now go on to my second coin. When I flip the second coin, I'm either going to get a heads or a tails. So this is the order it could have happened in. We could have got a heads and a tails. Does everybody understand that? Now, if I would have flipped a tails on my first one, my first event, when I flip my second coin, I'm still either going to get a heads or a tails. So now I've listed all the possible outcomes. I have a heads, a heads, tails, and a tails. So we had 1, 2, 3, 4 possible outcomes, right? Now the cool thing is with the tree diagram is you can just count the the very ends of the branches. So I had 1, 2, 3, 4. 4 total possible outcomes. Does that make sense? Yes. We're going to get into some huge tree branches later on, and even in this lesson. So it said, what is the sample space? The sample space was my tree diagram. And I listed it out like this. You don't have to do that because you can just refer to your tree diagram. Does that make sense? Okay? Now, how many outcomes? We said 4, right? And with tree diagrams, you can count the ends of your trees. Does everybody understand that? Okay, let's do a little bit more complicated one. Now pay close attention. This is the one on the worksheet that people did not know what they were doing. Okay, so this is the event. I'm flipping a coin. I'm flipping another coin for a heads or a tails. And then my third event is either getting a Reese's or a Twix. So I'm going to write this down. My first event is a heads or a tails. Second event is a heads or a tails. My third event is a Reese's or a Twix. So I'm going to make a tree diagram correctly. Now, people started doing this weird. I don't know what they were doing. We're listing the possible ways we're going to see our answers. You're not going to say nickel, penny, Reese's Twix, and then I don't know. I just saw some really weird things happening. All right, so let's focus on event 1. Now, these are the outcomes of event 1. We're going to flip and we're going to get a heads or a tails. Now we'll go on to event 2. We're going to flip our second coin, and after that happens, we're still either going to get a heads or a tails. Well, we still have this. After we flip the tails, we're still going to get on the second event either a heads or tails. Did I not explain that well, or does that make sense? Be honest, do I need to say that in a different way? Okay, you all get how I did that. So this is the orders and the possible outcomes of the first 2 events. Now, my third event, I'm going to do it in a different way. My third event is either getting a Reese's or a Twix. So I could have got a heads, then a heads, but I'm still going to get on my third one either a Reese's or a Twix, right, everybody? Now, let's say I would have got a heads, then a tails. On my third one, I'm still going to get either a Reese's or a Twix. Well, let's say that I would have flipped a tails and a heads on the third time. I'm still going to get a Reese's or a Twix. Do you see how I'm doing this? And then if I would have flipped a tails and a tails on my third one, I still would have got a Reese's or Twix. So now let's count the total possible outcomes. So now it says determine the sample space. This is the sample space. We can get a heads, a Reese's, a heads, a Twix, a heads, a tails, a Reese's, a heads, a tails, Twix. Tails, heads, Reese's, heads, tails, Twix. Tails, tails, Reese's, tails, tails, Twix. Tails, Twix. Okay? You guys understand the sample space? Okay. All right. Now, how many outcomes? Let's use our little trick on our tree diagram. We don't want to have to count all those. Just count the end. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 possible. 8 total. All right, so now looking at this, we had a 50-50 chance, right? These were all 50-50 chances, and this was 50-50 chances. So we can just go ahead and, since it was evenly, the probability was just evenly happening, we can just calculate it pretty easily here. So it said, what's the probability of getting at least 2 heads? How many times did that happen? Heads, heads, Reese's, heads, heads, Twix, right? So how many times did that happen? Twice out of how many? 2 out of 8. So I'm going to say that again. It says find the probability of getting at least 2 heads. So the only place is heads, heads, Reese's, heads, heads, Twix. Anywhere else there was no 2 heads. We had a heads and a tails, tails and a heads, tails and a tails. So does everybody see how it happens twice in our sample space? 2 out of 8. So then you do that in your calculator, and you get 25%. So there's a 25% chance of getting 2 heads. So let's find the probability of 1 heads, 1 tails, and a Reese's, landing on 1 heads, 1 tails, and a Reese's. So let's see how many times that happens in our sample space. Heads, tails, Reese's. That's heads, heads. Nope. Tails, heads, Reese's. Tails, tails. Nope. So how many times did that happen in our sample space? 2 out of 8. So that's 25% chance. Does that make sense? What's the probability of getting 2 tails exactly and a Twix? How many times do we get 2 tails exactly? Right there's 2 tails, right? 2 tails and a Twix. It only happens 1 time, right? In all the sample space, it happens once out of 8. So you'll be 1 divided by 8 in your calculator. What do you get? 12.5. Okay. Questions on this? Okay, now I'm going to show you something that it gets a little bit more advanced. Now notice in this problem, all of the probabilities were equally likely to happen. So we could just take the number of times that this event happened, like how many times getting 2 heads happened twice out of the total possible. But if you have weighted probability, meaning the probability is not even, then you've got to think about it a little bit further. So I have this same problem now, but read with me. So it says, if you're flipping the same 2 points, we still have the exact same tree diagram here, but now the probability of getting tails is 2/3. Does everybody understand how now the probability of getting tails is 2/3? So it's more likely to get tails than heads, right? What's the probability of getting heads?
1/3.
1 out of 3, right? If 2 out of 3 is tails, then 1 out of 3 would be heads. Does everybody understand? So we were given that the probability of getting a tails is a 2/3, right? So we know now instead of 50-50 chance, 2 out of 3 times you're going to get tails. So how many out of 3? If 2 out of 3 is tails, then that only leaves 1 out of 3 for heads. Does that make sense? Okay, so now you can go in and list those. Getting a heads is a 1/3 chance. This is a 1/3 chance. This is a 2/3 chance, right? Everybody following me? Tails is a 2/3 chance. Tails is a 2/3 chance. Heads is a 1/3. Now, is it still equally likely for Reese's and Twix? So it's a half and half, 50-50% chance. 50-50, I'll get a Reese's or a Twix. So I'm gonna write it as a decimal. 0.50, 0.50, 0.50. So now I have those probabilities listed. Okay. Okay, so it says, what's the probability of getting 2 heads? So when does that happen? It happens with heads, heads, Reese's, heads, heads, Reese's, and it happens with heads, 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 Twix. Now, these probabilities are weighted, so we can't just say 2 out of 8. They're weighted. So we've got to go through and multiply. We got to figure out what's the probability of getting a heads, and a Reese's. To find that probability, you multiply the individual probabilities. So you'll do 1/3 times 1/3 times 0.50. So 1/3 times 1/3 times 0.50. And then to find the probability of getting a heads, and a Twix, then you'll look at it. We have a heads, and a Twix. So the probability of getting heads, Twix is 1/3 times 1/3 times 0.50. So now if you calculate that, each of those, the probability of getting heads, Reese's is 1 out of 18. And the probability of getting heads, Twix is 1 out of 18. So we could write those as percents as well. So now if we have 2 of those, right? We have this and this. So we'll add them up. Okay, wow, people are really zoned out. Or is anyone even paying attention? So I'll take this 1/18 and this 1/18 and add them up because that's the 2 times that we get heads, right? But the probabilities were weighted, so we had to do that first. So now 1/18 plus 1/18 is 2/18, which is 11.1%. 11.1%. So I added this with this because those are the 2 times that happened, our weighted probabilities, and you get 11.1%. Questions? Yeah. I typed this into my calculator, it gave me a decimal, I changed it back to a fraction. Yeah. Any others? That was a good question. Any others? Okay. So now let's find the probability of getting a heads, a tails, and a Twix. So where does that happen? Heads, tails, Twix, head, tails, Twix, and then tails, heads, Twix. So tails, heads, Twix. So now you'll multiply those individual probabilities. Probability of getting a heads is 1/3. Probability of getting a tails is 2/3. And the probability of getting a Twix is 0.50. Probability of getting a tails is 1/3. Probability of getting a heads, tails is 2/3. Probability of getting a heads is 1/3. Probability of getting a Twix is 0.50. So if you type that into your calculator for this piece, you're going to get 11.1%. So 11.1%. You type this in, you'll get 11.1%. So how would I find the total percent? Add them together. So you're going to get 22.2% chance. So it's a 22.2% chance of landing on a heads, a tails, and a Twix. More likely, right? Do you see how these probabilities, even though we were doing the exact same thing, 2 heads, the probability of getting 2 heads was 11.1%. On the problem without it being weighted, the probability of getting 2 heads was 25%. Do you see how the weighted probability changes your answer significantly? Okay. All right, so now you're going to finish the worksheet. Ready, set, go.